Why aliens will ever find O's? Let me tell you something that should terrify you. Not because it means we're in danger, but because it means we're invisible. Completely, utterly, cosmically invisible. If there are intelligent civilizations out there, and there might be, they will never find us. Not because they're not looking, not because they don't have advanced technology, not because they don't care. They will never find us because the universe itself makes it impossible. The physics of detection, the mathematics of signals, the geometry of space-time, all of it conspires to keep us hidden. We are a whisper in a hurricane, a candle in a supernova, a single grain of sand on an infinite beach, and no one, no matter how hard they search, will ever pick us out from the noise. I'm Leonard Susskind, and I've spent 50 years thinking about the fundamental laws of nature. And the more I understand those laws, the more I realize that contact with extraterrestrial intelligence isn't just unlikely. It's essentially impossible. Not because aliens don't exist, that's a separate question, but because even if they do exist, even if they're actively searching for us right now with technology far beyond anything we can imagine, they still won't find us. The universe is too big, too noisy, too hostile to signals, and we are too small, too quiet, too recent to matter. Let me show you why. Start with the most basic problem. The problem that everyone underestimates because the numbers are too large for human intuition to grasp. Distance. The nearest star system to Earth is Alpha Centauri, about 4.37 light years away. That sounds almost manageable. 4 years of travel time for light. But let me put that in perspective. Light travels at 300,000 kilometers per second. In 1 year, light covers about 946 trillion kilometers. So Alpha Centauri is roughly 41 trillion kilometers away. If you drove a car at highway speed 100 kilometers per hour, it would take you about 47 million years to get there. Our fastest spacecraft, Voyager 1, traveling at 17 kilometers per second, would take about 75,000 years. And Alpha Centauri is the closest star. The Milky Way galaxy is 100,000 light years across. It contains somewhere between 100 billion and 400 billion stars. The observable universe contains about 2 trillion galaxies. The scale is incomprehensible, genuinely, literally incomprehensible to the human mind. Now, here's where this matters for detection. Signal we send out, any electromagnetic radiation that could reveal our presence, spreads out as it travels. It follows the inverse square law. The intensity of a signal decreases with the square of the distance from the source. If you double the distance, the signal becomes 4 times weaker. If you increase the distance by a factor of 10, the signal becomes 100 times weaker. 1,000,000 times the distance means 1,000,000,000,000 times weaker. Our most powerful radio transmissions, the ones we've been broadcasting into space for about a century now, become indistinguishable from background noise within a few light years. Maybe 10, maybe 20 if you're optimistic. Beyond that, they're gone, swallowed by the cosmic static. The universe is full of radio noise. Pulsars, quasars, magnetars, the cosmic microwave background radiation left over from the Big Bang. All of it creates a constant hiss of electromagnetic interference that drowns out any weak signal. Think about what this means. We've been broadcasting radio waves for about 100 years. That means our radio bubble, the expanding sphere of space where our signals have traveled, has a radius of about 100 light years. The Milky Way is 100,000 light years across. Our radio bubble covers about 1/1,000,000th of the galaxy's volume. 1/1,000,000th. And within that bubble, for most of its extent, our signals are already too weak to detect. An alien civilization would need to be within maybe 50 light years of Earth, have their antenna pointed directly at us, be listening on exactly the right frequency, at exactly the right time, we with detection equipment sensitive enough to pick out our signal from the noise. The probability of all those conditions being met simultaneously is essentially 0. But it gets worse, much worse. Let's talk about what we're actually broadcasting. When people imagine aliens detecting us, they picture something like the scene from Contact, a deliberate, powerful, clearly artificial signal beamed into space designed to be detected, containing mathematical patterns that prove intelligence. But that's not what Earth is broadcasting. We're not sending deliberate signals to the stars. We're leaking. Television, broadcasts, radio stations, military radar, cellular communications. All of it radiates into space as a byproduct of our technology. It's not aimed. It's not focused, not designed to travel interstellar distances. It's just noise that happens to escape into space. And here's the really bad news. We're becoming quieter, not louder. The transition from broadcast television to cable and streaming means fewer powerful signals radiating into space. The shift from analog to digital communications means our signals look more like noise, not less. Modern communication systems are more efficient, which means they radiate less wasted energy. The era of Earth being electromagnetically loud, that brief window of maybe 50 or 100 years when we were pumping out detectable radio signals, is already ending. In another century, Earth might be essentially radio silent. An advanced civilization looking at our solar system from 200 light years away in the year 2200 would detect nothing. Our radio bubble would have passed them by. The moment of our electromagnetic visibility, if it ever existed at all, would be over. We would have been a flash, A brief flicker of technological adolescence already faded into the cosmic background before anyone noticed. This is one of the proposed solutions to the Fermi paradox, you know. The idea that technological civilizations go through a brief radio, loud phase, and then become radio quiet, either because they destroy themselves or because they develop more efficient technologies that don't leak signals. If this is true, then the galaxy could be full of civilizations and none of them would be able to detect each other. Everyone is hiding in plain sight, screaming into a void that swallows all sound. Now let me talk about something even more fundamental, the geometry of detection. Imagine you're an alien astronomer far more advanced than us, with telescopes and sensors beyond anything we can conceive. You're surveying the galaxy, looking for signs of intelligent life. How do you do it? You might look for radio signals, but we've already discussed the problems with that. Signals fade quickly. They're drowned by noise. The timing has to be perfect. You might look for optical signals, laser pulses perhaps. But lasers are directional. Unless the civilization is deliberately aiming at you, you won't see anything. And why would they aim at you specifically? They don't know you're there. You might look for biosignatures, chemical signs of life in planetary atmospheres. Oxygen combined with methane, for instance, indicates biological activity. But biosignatures tell you about life, not intelligence. Bacteria produce biosignatures. Bacteria are not going to respond if you try to communicate. You might look for technosignatures, signs of technology, megastructures like Dyson spheres, artificial lights on the night side of planets, industrial pollutants in atmospheres, heat signatures from energy use. But all of these require the civilization to be using enormous amounts of energy, far more than we currently use. And they require the civilization to be using that energy in ways that are detectable across interstellar distances. Which brings us back to the same problem. Distance kills signals. The inverse square law is merciless. Here's a calculation that should disturb you. The total power output of human civilization is about 18 terawatts. That's all of it. Every power plant, every car engine, every light bulb, every computer, everything. 18 terawatts, the sun outputs about 386 billion terawatts. Our entire civilization's energy production is about 1/10 billionth of what the sun puts out. From the perspective of an alien astronomer looking at our solar system, the sun completely overwhelms any signal from Earth. We're a tiny, dim speck orbiting a blazing furnace. Picking out our technological signature from the sun's glare is like trying to see a firefly hovering next to a searchlight from a mile away in a thunderstorm. Even if you could somehow filter out the sun's light perfectly, Earth's technological signature is still tiny. Our artificial lights visible from space represent a few terawatts at most. Our heat signature is barely distinguishable from natural geological processes. Our atmospheric pollutants, while detectable in principle, would require spectroscopic observations of extraordinary precision, sustained over long periods, focused on a planet that you already knew to investigate. You'd have to be looking for us specifically, deliberately, with enormous resources dedicated to the search. And why would you look at this particular star, this particular planet, among hundreds of billions of possibilities? The galaxy is full of stars. Most of them have planets. A significant fraction of those planets are in the habitable zone, where liquid water could exist. There's no sign pointing to Earth saying intelligent life here. We're one data point in an ocean of data points, and there's no reason for anyone to pick us out from the crowd. This is the tyranny of large numbers. Even if your detection technology is incredibly good, even if you can scan thousands of stars per day, even if you have automated systems searching for anomalies, the sheer number of stars you'd have to survey is overwhelming. And the probability that any given star harbors a technological civilization that's currently in its brief radio loud phase, or that's currently building megastructures, or that's currently doing something detectable, is vanishingly small. The search is not just hard, it's statistically hopeless. Let me talk about time, because time makes everything worse. The universe is about 13.8 billion years old. Earth formed about 4.5 billion years ago. Life appeared on Earth about 3.8 billion years ago. But for most of that time, life was single-celled. Microbes, bacteria, nothing complex, nothing intelligent, nothing technological. Complex, multicellular life only emerged about 600 million years ago. Intelligent life, meaning us, appeared maybe 300,000 years ago. Technological civilization, the kind that broadcasts radio waves and builds machines, has existed for about 200 years out of 4.5 billion. That's 0.004% of Earth's history. If you were an alien astronomer surveying Earth at any random moment in its 4.5 billion year history, the probability that you'd happen to look during the brief window when technology exists is essentially zero. For 99.99996% of Earth's existence, there was nothing to detect. No signals, no megastructures, no technosignatures of any kind. Just a pale blue dot with an oxygen atmosphere. Maybe some signs of biology if you look closely, but nothing that screams intelligence. And here's the really disturbing implication. If this is true for us, it's probably true for everyone. Any technological civilization that arises probably has a brief window of detectability, maybe a few thousand years. maybe less. Before that window, they're invisible. After that window, they're either extinct or they've transcended into forms we can't recognize or detect. The window of mutual detectability, where two civilizations are both technological and both broadcasting and both listening and close enough to actually detect each other, that window might be extraordinarily small. Centuries, maybe, out of billions of years. Think about what this means. The galaxy could have hosted millions of civilizations over its history, but if each one only had a few centuries of detectability, and if they arose at random times over billions of years, the probability of any two being detectable simultaneously is almost zero. Ships passing in the night doesn't capture it. It's more like ships passing in an ocean that takes millions of years to cross, each one visible for only a few seconds as they pass. We're not looking for aliens. We're looking for aliens who happen to exist right now within a few hundred light years, who happen to be broadcasting in our direction at frequencies we're monitoring with enough power to be detected. The conjunction of all these probabilities is vanishingly small. Now let me address something that optimists always bring up. What about deliberate attempts at contact? What about METI? Messaging extraterrestrial intelligence? What about civilizations that actively want to be found? Even here, the physics is brutal. Let's say an advanced civilization decides to announce its presence to the galaxy. They want everyone to know they exist. How do they do it? They could build a powerful transmitter and broadcast in all directions. But broadcasting in all directions means spreading your energy over the entire celestial sphere. The power density in any given direction is tiny. To be detectable across galactic distances, you'd need a transmitter of almost inconceivable power. We're talking about the energy output of entire stars focused into a coherent beam. This is not impossible in principle, but it's so far beyond current human technology that we can't even estimate the engineering requirements. They could aim their transmitter at specific targets. This is more efficient, but it requires knowing which targets to aim at. And it requires those targets to be listening when your signal arrives. If you aim a signal at a star 10,000 light years away, your signal takes 10,000 years to arrive. You have no idea what's happening at that star 10,000 years from now. Maybe a civilization will have arisen by then. Maybe not. You're shooting into the dark, hoping someone will be there when your message arrives, millennia after you sent it. They could send physical probes. Self-replicating von Neumann machines that spread through the galaxy, seeding every star system with beacons or transmitters. This is the most plausible way to really make yourself known, to really ensure that anyone who arises anywhere in the galaxy will find your message. But even this takes millions of years. The galaxy is 100,000 light years across. Even at a significant fraction of light speed, colonizing the entire galaxy takes hundreds of thousands of years. And you have to maintain your civilization, your infrastructure, your commitment to this project for that entire time. Civilizations change, they collapse, they transform. The project that seemed important a million years ago might be abandoned, forgotten, meaningless to whatever your descendants. And here's the thing, we've been looking. Actively looking for over 60 years. SETI, the search for extraterrestrial intelligence, has been scanning the skies for radio signals since 1960. We've surveyed millions of stars. We've listened on billions of frequencies. We've looked for optical signals, infrared anomalies, any sign of artificial origin. And we've found nothing, absolutely nothing. The silence is deafening. Some people argue this proves aliens don't exist. I don't think so. What it proves is that if aliens exist, they're not doing anything we can detect. Either they're not there, or they're not broadcasting, or they're broadcasting in ways we can't recognize, or their signals are too weak, or the timing is wrong, or we're looking in the wrong places. The silence doesn't tell us aliens don't exist. It tells us that detecting aliens is really, really hard, possibly impossible. Now let me talk about something that physics forces us to confront: the nature of signals themselves. What does it mean to send information across interstellar distances? Any signal is a pattern of electromagnetic waves, or a pattern of physical objects, or a pattern of something else. To detect a signal, you have to distinguish it from noise. You have to recognize the pattern. And here's the problem. At interstellar distances, entropy degrades, pattern noise accumulates, interference distorts, the signal becomes increasingly indistinguishable from random fluctuations. Think about it this way. Imagine you're trying to listen to a whisper from across a football stadium. But the stadium is full of people talking. There's a thunderstorm overhead, and someone is playing a jet engine next to your ear. That's what detecting an alien signal is like. The whisper might be there, the information might exist, but the noise is so overwhelming that you can never pick it out. The cosmic microwave background radiation fills the entire universe with electromagnetic noise at a temperature of about 2.7 Kelvin. This sets a fundamental floor on how sensitive your detectors can be. Quantum mechanics also imposes limits. The Heisenberg uncertainty principle means you can never have perfect knowledge of a signal's frequency and timing simultaneously. There are fundamental physical limits to detection, limits that no technology can overcome because they're built into the structure of reality itself. And there's another problem: bandwidth. The electromagnetic spectrum is vast, but the amount of it that we can practically monitor is tiny. We've surveyed a minuscule fraction of possible frequencies. We've looked at a tiny fraction of the sky. We've done it for a cosmically insignificant amount of time. 60 years out of billions. Imagine trying to find a specific needle in a haystack the size of a galaxy, and you're only allowed to search one straw per century. Let me tell you about the coordinate problem. This is something that doesn't get discussed enough. For two civilizations to communicate, they need to agree on where and when to look. They need a common reference frame, a meeting point in the vast ocean of space-time. We assume that radio frequencies near the hydrogen line are natural Schelling points, places where civilizations might naturally converge for communication, because hydrogen is the most common element and its emission frequency is universal. But this is assumption, human assumption, based on human physics and human reasoning. An alien civilization might think completely differently. They might use gravitational waves instead of electromagnetic waves. They might use neutrinos. They might use methods of communication that we haven't discovered yet, that we can't even imagine. And even if they use radio, they might choose different frequencies for reasons that make sense to them, but not to us. They might encode their signals in ways that look like noise to us. They might compress their data so efficiently that it appears random. We don't know what alien technology looks like. We don't know what alien communication looks like. We might be surrounded by alien signals right now, and we wouldn't know because we don't recognize them as signals. This is the problem of recognizing intelligence. We assume we'll know it when we see it. But intelligence might take form so alien that we can't comprehend them. Communication might use principles we haven't discovered. Technology might operate on scales we can't perceive. We're like ants trying to detect human radio broadcasts. The signals pass right through us, but we have no way of knowing they're there. Here's something else that should worry you. The speed of light is not just a speed limit. It's also an information barrier. Nothing, including information, can travel faster than light. This means that communication across interstellar distances is fundamentally limited. A message to Alpha Centauri takes 4.37 years to arrive. A message to the center of the galaxy takes 26,000 years. A message to the Andromeda galaxy takes 2.5 million years. Any conversation across these distances is not a conversation. It's an exchange of monologues separated by spans of time longer than civilizations typically last. You send a message, you wait thousands of years for a reply. By the time the reply arrives, your civilization has transformed beyond recognition, or collapsed, or transcended. The beings who receive the reply might not even remember that a message was sent. This is why I think contact, in the sense people imagine it, genuine two-way communication between civilizations, is essentially impossible. The universe is structured in a way that isolates civilizations from each other. The distances are too vast. The speeds are too slow. The windows of mutual existence are too brief. Physics itself imposes a kind of cosmic quarantine. Everyone is trapped in their own bubble of space and time, able to look out at the stars, but never able to truly reach them. Does this mean we should give up? Should we stop searching, stop listening, stop hoping? No, I don't think so. The search for extraterrestrial intelligence is still scientifically valuable. Even negative results tell us something about the distribution of life in the universe. And there's always the possibility, however small, that I'm wrong, that the universe has surprises we can't anticipate. That some civilization has found a way to overcome the barriers I've described. But I think we need to be realistic. We need to stop expecting contact. We need to understand that the silence we hear is probably permanent. Not because we're alone, but because the universe is too big, too old, too noisy, too indifferent to allow connection. The same laws of physics that made our existence possible also make our detection almost impossible. We are hidden, cosmically, absolutely, inevitably hidden. An alien civilization could be searching for us right now with all the resources of a galaxy spanning empire, and they would never find us. We are too small. Our signals are too weak. Our window of visibility is too brief. By the time any hypothetical searchers notice that something interesting might have happened on the third planet of an unremarkable yellow star, we'll be long gone. Extinct or transformed, or simply forgotten in the vast sweep of cosmic time. This is not a tragedy, it's just physics. The universe isn't cruel, it's indifferent. It operates according to laws that don't care whether civilizations meet or remain forever alone. The inverse square law doesn't have malice. The speed of light isn't punishing us. These are just facts about reality, as impersonal and absolute as the equations that describe them. But there's something profound in this isolation, something that should make us value what we have. If no one is coming to find us, then we're on our own. This planet, this civilization, this brief flicker of consciousness in the cosmic dark, it's all we have. There's no rescue coming, no elder civilization to guide us, no galactic federation to join. We are alone with ourselves, and we will remain alone probably forever. That's a heavy burden. But it's also a kind of freedom. We don't have to live up to anyone's expectations but our own. We don't have to wait for contact that will never come. We can make our own meaning, our own purpose, our own future, without reference to civilizations we'll never meet. I've spent my career trying to understand the universe. And the more I understand, the more I appreciate how rare and precious intelligent life might be. We might be the only ones, or we might be one of millions, scattered across the cosmos, forever isolated, forever searching, forever alone. Either way, what we do here matters. Not because anyone is watching, but because we're the only ones who can do it. The aliens will never find us. That's what physics says. And after 50 years of listening to what physics says, I've learned to believe it. But that doesn't mean our existence is meaningless. It means our existence is ours, completely, entirely, irreducibly ours. And maybe that's enough. Look up at the stars tonight. Think about all the light traveling toward you from unimaginable distances. Some of that light left its source before Earth existed. Some of it has been traveling for longer than there has been life on this planet. And none of it carries a message. None of it is meant for you. It's just light spreading through the void, illuminating nothing, meaning nothing, until it happens to hit a retina attached to a brain capable of wondering what it all means. We're the ones who give it meaning. We're the ones asking questions. And we might be the only ones who ever will. That's terrifying and beautiful in equal measure. And it's probably the truth. Thank you for listening. Keep looking up. Not because you'll find anyone looking back, but because the looking itself is what makes us human.